Hello everyone. In this video, we are going to talk about worksheet 9, which is about derivatives, and it is about using chain rule and quotient rule. First question is 1 over x. We talked about 1 over x before using the power rule by writing it as x to the power -1. But in here, we are going to find the derivative using the quotient rule. So for using quotient rule, we would say that derivative of the top, which is 0, multiplied by derivative multiplied by the numerator itself minus derivative of the bottom, which is 1, multiplied by the top, all over numerator to the power 2. So we know that 0 multiplied by x is just 0, so the top would be -1 over x squared. And I highly recommend to memorize this. Number 2 can be also done by writing this as x to the power -2 and then use power rule. But in here, we're going to use quotient rule. So quotient rule says derivative of the top, which is 0, multiplied by the numerator minus derivative of the numerator, which is 2x minus maybe I said wrong. Derivative of the numerator, which is 0, multiplied by denominator minus derivative of denominator multiplied by numerator all over denominator to the power 2. It is x squared, so it will be raised to the power 2. Altogether, the top will be -2x over x to the fourth, and then by simplifying, we would get -2 over x cubed. Number 3 and 4 here. Number 3 is product rule. You can simply multiply these two and then use product rule, or you can start using product rule from here. Either is fine. So f prime of x is copy the first one, derivative of the second one, which is cosine of x minus sine of x, plus copy the second one, which is sine of x plus cosine of x, and multiplied by derivative of the first one, which is e to the x. So we can factor out e to the x, and then we are left with cosine of x minus sine of x plus sine of x plus cosine of x. So these two will cancel out, and then we would have 2 e to the x cosine of x as the answer. Next one is obviously quotient rule. So f prime of x is derivative of the top, which is -3 sine of x plus, not plus, minus secant squared of x times the numerator minus derivative of the numerator, which is 1 plus 20 x to the fourth multiplied by the denominator, which is numerator, cosine of x minus tan x. All over the denominator to the power 2. And we would leave it as is because we cannot simplify this much and it doesn't worth it. So number 5, is here. 3 of them we can do at the same time. So 5, the first part is a product rule because t and cosine, they are multiplied together. So we have two parts here. Each of them has variable. So it is a product rule. But this part is not a product rule because 2 over 5 is just a coefficient and this is the function. So we would start with using product rule for the first one. It says copy the first one, derivative of the second one, which is negative sine of t, plus copy the second one, and derivative of the first one, which is 1, minus, we would write 2 over 5 as the coefficient, and we know that the derivative of cotan is cosecant. So cosecant squared of t. We have negative here. Oh, here it has negative. So we can combine these and write it as negative t sine of t plus cosine of t and then plus 2 over 5 cosecant squared because the derivative of cotan is negative cosine squared and we have a negative here. Next one is again quotient rule. So f prime of n and the variable here is n. It will be the derivative of numerator, which is 2, multiplied by the denominator, minus derivative of the bottom, which is 5m to the fourth plus 7, multiplied by 2m minus 1, all over m5 plus 7m to the power 2. We can distribute and we would get 2m to the fifth plus 14m minus 5m to the fourth, which will be multiplied by 2m. So we would have negative 10m to the fifth plus 5m to the fourth plus 7 all over m to the fifth plus 7m squared. And you can simplify somehow, and we would end up with negative 8m to the fifth plus 5m to the fourth plus 14m plus 7 all over m to the fifth plus 7m squared. It's a little bit simplifying. So let me erase the board and then do 7. For 7, f prime of x, it can be done by quotient rule and also it can be done using power rule. So we can write it as x over x to the power 2 over 3 plus square root of x over x to the power 2 over 3. If we do this, it will be x to the power negative, so 1 negative 2 over 3 plus x to the power 1/2 minus 2 over 3. And you can follow this to take derivative. And I think it is easier than using quotient rule, but you can use quotient rule also. So if we pick this one, the answer will be, so let's simplify this. It will be x to the power negative 1 over 3 plus x to the power, so for these two, the LCM will be 6, so it will be 3 minus 4, which is negative 1 over 6. Now, taking derivative is easy now. It will be negative 1 over 3, x to the power negative 1 over 3. So let me see. 1 minus 2 over 3 is positive, not negative here. This is positive. Okay, 1 over 3 minus 1 will be negative 2 over 3. And x to the power negative 1 sixth, when we take derivative, will be negative 1 over 6 x to the power negative 1 over 6 minus 1, which will be negative 7 over 6. Let's move on. Okay. Number 8 is product rule. So we would follow product rule. It says copy the first one, derivative of the second one, plus copy the second one, and derivative of the first one, which is 4t cubed. We can simplify somehow. We can factor out 3 t cubed. So we're left with negative t sine of t plus 4 cosine of t. And that's it. Next one is the apparently quotient rule. So it says derivative of the top, which is 5, multiplied by x plus 5 over x minus derivative of denominator, which is 1 minus 5 over x squared. If you remember, I have talked about remembering derivative of 1 over x, which is negative 1 over x squared. And then since it is 5, it will be 5 also. So it is a good idea if you remember that. Multiplied by top all over x plus 5 over x squared. So by multiplying, we would try to simplify. It will be 5x plus 25 over x minus 5x plus 25 over x all over x plus 5 over x squared. So they will cancel out. It will be 50 over x plus 5 over x squared. And we can write it as 50 over x times x plus 5 over x squared. Number 10 is also product rule, and you can distribute using foiling to find the polynomial and then take derivative. Either is fine. So we would use product rule here. Copy the first one, derivative of the second one, plus copy the second one, derivative of the first one. And we can simplify somehow. It will be y plus 4y squared plus 1 plus 4y. Altogether, we would end up with 6y squared plus 6y plus 1. Let's move on. It will be number 11 now. The mental equation for the enzyme chymotrypsin is defined by this quotient, where nu is the rate of an enzyme reaction and brackets S is the concentration of a substrate S. So this is not a function, this is just a notation. Calculate dVd bracket X S and interpret it. So we would treat it as a variable. d nu d bracket of S, let's say d nu dx, something like that. And since it is a quotient, at the top and the bottom we have variable, so it will be quotient rule to find the derivative. To use quotient rule, it would be derivative of the top, which is 0.14, multiplied 0.015 plus this sign minus derivative of the bottom. So the first one is just a constant, which has the derivative of 0, and the other one is, let's say, imagined as x. The derivative would be 1 multiplied by 0.14 bracket s. All over whatever we have here, power 2. After simplifying, you would get 0.0021 all over 0.015 plus bracket s power 2. And the interpretation for this means whenever the derivative, which is the rate of change of enzyme reaction rate with respect to the concentration of the substrate, is this one. So this is basically defining what dVds is, which is this much here. And you can plug in bracket x whenever you have an amount for that. Number 12, suppose that f of 2 is equal to -3, g of 2 is 4, f prime of 2 is -2, and g prime of 2 is 7. Find h prime of 2, where h is defined by this fraction. So following the quotient rule, it will be derivative of the top, which is g prime of x, multiplied by 1 plus f of x. It is not bracket as a function. It is just, let's say, parentheses, minus derivative of the denominator, which is f prime of x, multiplied by numerator, all over 1 plus f of x squared. Now it is time to find this at 2. We have different amounts here. We would replace them here. So g prime of 2 times 1 plus f of 2 minus f prime of 2 multiplied by g of 2 all over 1 plus f of 2 squared. Using the amounts that is given to us, it will be 7. This one is 7. This one is -3. This one is -2. This one is 4. And also this one is -3. So altogether, -3 over 2 is the answer. Next one, number 13. If f of x is x plus y, find f prime of x. It means that x is the variable and any letter rather than x is not variable. Also, it seems to be a variable. It seems to be a letter that usually we consider them as variables, but it will be a constant. So this one here is a constant. So it doesn't matter whenever you have y as the constant, or the question was about finding the derivative of x plus 2. So they are basically the same. Now, let's go back and do it. F prime of x is equal to derivative of the first one, which is 1, plus derivative of this one, which is a constant, which is 0. So derivative of f of x is 1. Same idea here. It says f prime of y. It means that this part has variable, but the other part does not have any variable. It means that it is constant. So f prime of y will be derivative of the first part, which is derivative of x, and x is not variable. It will be 0. Minus um, negative 3y to the fourth, when y is variable, has the derivative of negative 12y cubed. So this is the answer. 15, let's read it. If the frequency of a gene for insecticide resistance is P, then its frequency in the next generation is given by the expression P times 1 plus S over 1 plus SP, where S is the reproduction advantage that this gene has over the wild type in the presence of insecticide. Determine the rate at which the gene frequency in the next generation changes at S as S changes. So it basically is talking about rate of something. It means that whenever you have rates, think of finding derivative. And in this case, since as S changes, we would find D of whatever we have, ds. We have P, we have S. And the question is, which one is the variable? So P, 1 plus S, 1 plus SP. Since the question says find the rate when S is changing, so S is the variable now. Okay, for simplifying, I would like to bring out P, which is not derivative, which is not variable here. We treat it as a constant, like 2. So ds of the whatever is left here. So P is here. Now, derivative of this fraction with respect to S, it will be derivative of the top, which is 1 because S is the variable, and derivative of this 1 here is z times 1 plus SP minus derivative of the bottom here. We know that derivative of 1 is 0, and derivative of this part with respect to S is okay, so with respect to S is P times 1 plus S all over 1 plus SP squared. We can simplify somehow. So if we multiply them, we would get, let's keep P here, 1 plus SP minus PS minus 1. Minus P, sorry. So they are gone, and this is the same. So all together, we would have P times 1 minus P all over 1 plus SP squared. Number 16 is reciprocal formula. You don't have to memorize this, but based on my experience, it is good if you remember this formula. It helps and saves time. So whenever you have a reciprocal of something, you can find the derivative directly without following the quotient rule or maybe power rule. By writing the derivative as negative, the derivative of the numerator, whatever it is, over the numerator square. Let's do it for this formula, this function here. If I don't remember the reciprocal rule, I would use quotient rule here and say, okay, derivative of the top multiplied by the bottom minus derivative of the bottom, and then multiplied by top all over the bottom itself to the power 2. It is completely correct. But sometimes, like this, we can use reciprocal rule and get the answer easier. So it will be negative derivative of the function that you have in the denominator, which is 12x squared minus 2x all over the denominator itself, power 2. You can use quotient rule, simplify, and you have to have this one as the answer. But this way is kind of faster and I think easy.